The title of this presentation is Inspection of Human Vision by Using the Photographs on Rotating Propeller. At the beginning, I would like to talk about the objective of this study. The inspection was try to confirm the unconscious mechanism of human vision. Although human is able to control vision by the language activity, the newly added conscious activities are overlapping to the unconscious activities. The point of study is the processing of human vision to recognize the direction of rotation. The investigation of human vision was carried out by comparing the series of still images with the video that is replayed at 30 frames per second. Here, the pictures were captured on a rotating propeller, in which one blade is marked without change of the shape. The image that is reflected in the retina is changing in accordance with time. By fixing time, we can recognize the space arrangement. The time must be fixed to understand the space arrangement. A shutter fixes the time for capturing an image. The photographs of this report were taken by using a digital camera Casio XFH100. The propeller was rotated by a motor, of which axis is connected to the propeller via gearbox in order to avoid rolling shutter effect. A series of pictures at upper portion were captured with low rotation speed of propeller that was decelerated by gearbox of 719 versus 1. When the thing of object moves during opening of the shutter, the flowing image is captured. On the other hand, this series of pictures at lower portion were captured on high rotation speed of propeller that was decelerated by gearbox of 101 versus 1. The rotation of a propeller is recognized by the still image that flowed. In the case that period of shutter fixed, we can estimate the speed of rotation by the picture that flowed. That is, the speed of rotation is recognized by the pattern matching of the still image that is flowed. But recognition of rotational direction is not achieved by one piece of still picture. The recognized direction of rotation depends on the shortest shift of the angle between images before and after. A series of pictures at upper portion were captured with 30 frames for 1 second at low rotation speed of propeller. It is difficult to decide the direction of rotation on a white blade. However, the white blade is rotating clockwise in the photographs of the lower part that was photographed with 120 frames per second on the same rotation without changing the speed of rotation on propeller. The direction of rotation is recognized by comparison of before and after. That is, the vision relies only on the image that was captured. The movie is operated with about 30 frames per second. Here, each picture was captured at high speed of shutter, at 0.8 milliseconds. The frame rate of photographing was changed from 30 frames per second into 120 frames per second. The vision depends on the pictures those were captured. Two rotational directions exist in the same propeller in the series of pictures. That is, if we pay attention to the white blade, we can recognize clockwise rotation. If we pay attention to the whole blade without regard to white color, we can recognize counterclockwise rotation. We could not recognize counterclockwise rotation for a propeller without paying attention to the shape of propeller. When those images are replayed as movie, we recognize clearly counterclockwise rotation on the propeller. It is considered that the recognition of shape on the image is recognized at first. In case of a series of still pictures, we estimate that clockwise rotation for a white blade. Even in case of movie, we can recognize clockwise rotation on white blade, if we pay attention to the white blade. There is difference of priority on recognition between conscious and unconscious. In this case, that unit shift of blade is slightly larger than 1 plus half. The deviation of shift on the propeller without mark changes the shortest distance blade, and caused the change of the recognition on rotational direction. In the series of still pictures, the shifting of the inclusive shape on propeller is difficult to notice, but it is recognized sensitively at the recognition of movie. The rotation of the blade changes the direction from counterclockwise to clockwise, if these pictures are replayed as a movie. The shifting of the inclusive picture is recognized sensitively at the recognition of movie. In this series of still pictures, unit shift of white blade is slightly larger than 180 degrees for each frame. So, it is estimated that the white blades will be rotating counterclockwise. However, it is estimated that the shape of propeller is rotating towards clockwise. But, the recognition of rotational direction on the white blades is the same with whole blade. In this movie, the recognition of rotational direction on the white blades is the same with whole blade. From this movie, we can consider the mode of recognition that is given to the recognition on inclusive image. In this movie, the recognition of rotational direction on the propeller is counterclockwise. But, from these still pictures, it is estimated that a white blade and two red blades is rotating towards clockwise. The rotational direction of shape on a propeller can be recognized if we ignore of the color of blades. That is, the rotational direction of the shape of propeller is counterclockwise. From this fact, we can consider that the priority is given to the recognition on the shape more than to the recognition on the color. This is the movie that shows the distortion on image caused by rolling shutter of CMOS sensor. When we capture a photograph on a propeller of a high speed of rotation by using the digital camera that implemented a CCD sensor, a distorted image is captured. The rolling shutter reads out the data by scanning similar to that of cathode ray tube. Capturing of data is delayed at the scanning of the lower part of the propeller. The image of the lower part of the propeller is shifted clockwise when the propeller turns clockwise. Moreover, the flow of image increases in the right side, because the period of opening of shutter increases in the right side. Both effects are combined, and the distorted images are observed. The still pictures show the distortion of rolling shutter. Those pictures were captured at frame rate is 120 frames per second, and shutter speed is 0.8 millisecond for a shot. Here, the propeller was turned by an electric motor directly, without using a deceleration gear. Conclusions. Rotational speed of the propeller is recognized by a pattern matching of the still image that is flowing. The flow in the picture is decided in relative relation between the moving speed and the speed of shutter. The recognition of rotational direction is done with the comparison of the image between before and after. In comparison with the analysis on still pictures, the priority is given to the recognition of rotational direction on the broad shape. In dynamic vision, the judgment of the general situation has priority compared with that of focused attention. Thank you for your attention.